This is the Junior Kangaroo from 2024. Let's just get straight into it. Which of these umbrellas isn't this umbrella? Well, if you look closely at C, this R is backwards compared to this G as you're reading around. This R is the wrong way around, so therefore that's the wrong one. Here, if I paint this one black and maybe this one grey, then there's going to be no same colours next to each other. And so that's two changes I've made to make that work. And since 2 is the smallest available answer, I'm confident that that must be the correct answer. 12 ducks, 3 of them lay an egg every day for 12 days, so that's 3 lots of 12. 4 of them every other day, so that's 4 lots of 6, because there are 12 days in total. So every other day is 6 days, there's 4 of them that do that. And then 5 ducks every 3 days, so that's going to be 4 lots of times you get 5 ducks laying, so that's 5 lots of 4. Add the results together, you get 80. Which of these is closest to 2? Well, as the numerator and denominator get closer together, the fraction is going to get closer and closer to 2. If you imagine something like, I don't know, 2,000,001 over 1,000,000, that's incredibly close to 2 compared to this. So the answer is just immediately going to be E without any calculation needed. These people are playing a game. The winner gets 3 and the loser gets 1. Aman wins 6 games. Sophie gets a total of 18. So if he wins 6 games, 6 of her points are from losing, because when you lose, you get 1 point. So 6 of these 18 points are from her losing, which means 12 of the 18 come from her winning, which means she won 4 games. So the answer is 4 plus 6 to make 10 games in total. Number 6, the 2 dogs add up to make 80, and 1 dog is 20 less than the other dog, is essentially what this says. So you're looking for 2 numbers that add to make 80, where 1 is 20 less than the other. That would be 50 and 30. Holly's is the bigger one, so that would be 50 as the answer. Either 2 leaves and 1 flower, or 5 leaves and no flowers. Now, the key here is the fact that the second type of flower, we'll call the flowers A and B maybe, the second type of flower has no, or the second type of plant, sorry, has no flowers. So in total, if they have 6 flowers, all those flowers must be from type A, or plant number A. So there must be 6 of plant A, which leaves, of course, well, if 6 plant A, they've got 2 leaves, that's 12 leaves. Take away that from that, that's 20 leaves in total. B has 5 leaves each, 5 leaves each, so of course 20 leaves that you're missing, that must be 4 lots of B. And then you add them together and you get 10 plants in total. Here, for these two things to make a distance of 50 across, they must each have length 30, because you get 30, and then when you minus this 10 from this 30, you get another 20, or you can think of it as 20, then 10, then another 20, but that will definitely make 50. So now to do this, to make a strip 56 centimeters long, all we kind of have to do is pull this second one out by 6 centimeters to make the whole thing longer by 6, which will, of course, reduce this overlap down to 4. And so the overlap will be 4. Or you could just try finding the numbers that make it do it. It's kind of up to you. These questions are always great. What's the perimeter here? Well, there's clearly 3 perimeter on the bottom, just because 1 plus 1 plus 1. There's also kind of clearly 3 perimeter vertically, just 1 plus 1 plus 1. So I'm not bothering counting the horizontals yet. I'm just saying it's 1, 1, and 1. And likewise here, 1, 1, and 1. So there's 3 perimeter on either side. And then horizontally from the top, well, actually, I can just see that it's going to also be 3, because there are all these horizontal segments that start here and end up over here, which is a distance of 3. So therefore, this plus this plus this plus this plus this must be 3. And it doesn't matter where you put these blocks, whether you move them left and right. The perimeter is just 12. You can kind of think of it in terms of like if you shoved all of these as far across the right as possible, you could then just add up some of these numbers. It would still be 12, but it just doesn't matter where you put those blocks at all. The date with the highest number is going to be the 29th of something, and that something will be 09. It's tempting to think that it would be like the 12th month, but 09, of course, is going to add up to more than 12. So just add those numbers up, you get 20, not a hard problem at all. 9 houses in a row, at least one person lives in each house. Any 2 neighboring houses have at most 6 people. So, okay, what I started doing was just have 9 houses with 3 people, because then neighboring houses have at most 6. Every house has at least 1 person in it. And this adds up to make 27. However, 27 isn't the biggest answer available. So I do need to think about whether there's some way to juggle these to get a higher number. And I read this sentence and thought, well, okay, so they're stopping me from doing houses of 0 then. So, well, let's just do this then. It just seemed like a bit of a, like they've written it here, so maybe I should be thinking about it. So I changed it to 5, 1, 5, 1, 5, 1. And actually, because you end up increasing 1 more lot of 5 than you do decreasing down to 1, this actually adds up to 29, and I figured that must be right. There can't be any way of improving that, I don't think, because of this at least 1 rule here. means I can't really juggle anything else around in that way. We have a rectangle here. PQ is 1. Now, of course, because we can see that 2 widths make up a height, we can say each width is a half. So the thing across here is a half plus 1 plus half, which is 2. And that will be our answer for that one as well. So use decimal multipliers here. 0.2 times 0.3 of x is 0.3 times 0.4 minus 3 of x minus 3, I should guess as I say. So 20% of 30% of the number is the same as 30% of 40% of the number, then take away 3. Because this is 3 less. So we'd have to take away 3 from this one to get down to this one, I guess. Anyway, just multiply that out. And then maybe take away 0.06x and add 3, and then, or times by 100, sure, whatever. It's going to work out in the end, get the answer of 50. You could also have just tried all the answers, of course. Always a good strategy. Find 20% of 30% of this, and then check whether it's 30% or 40%. That would be quite a long thing to do in this question. Although what I would say is if you are going to go with the trying numbers strategy, always start on the right-hand side. Because I still feel that when they write these papers, on any question where they expect that people will try out the answers, they put the answer over on this side just to mess with people because they know they're going to start from left to right. So start on the right. Anyway, now that I've said that, of course, and everybody in the world watching my videos, they're going to start putting the correct answer on the left, but who cares? The area of a rectangle is 12. Length of its sides are integers. So I just drew all the rectangles that could do that and worked out all their parameters. And this is the only one that has an answer that's on the thing, which is 26. And so the answer is 26. Here, x has to be red, right? Because this triangle here has to have a red side, and it can't be here because of this red side, and it can't be there. So this has to be red. So the only acceptable answers here are either only red, or it's not possible if there's actually no way to continue this. So let's just try and continue. Well, we can see that this also has to be red, because this can't be red, and this triangle has to have a red side. So we'll go red there, this has to be green therefore, then this has to be blue, then this has to be green, then this has to be blue, and that all works out. So it's going to be the answer of only red. We've got 3 green apples, 5 red apples, 3 blue pears, and 2 yellow pears. He takes out some fruit, 2 fruit pieces of fruit. How many to be certain he has at least 1 apple and 1 pear of the same color? So when we're doing this, we're saying, okay, what's the worst case scenario? And the worst case scenario, I guess, is that he takes out 7 green pears in a row and then 5 yellow apples in a row, or the other way around, it doesn't matter. But now we've taken out 12 pieces of fruit and none of them match, either by color or by type of fruit. However, when he takes out the 13th piece in this scenario, he must be taking either a green apple, which would match with this green pear, I guess, for this rule, or a yellow pear, which would match with this yellow apple for the rule. So the 13th one will cause a match, and the answer is 13. And again, because there's no bigger answer, I know that this must be the correct answer as well. I mean, I knew it anyway, but whatever. This one took a bit of thought until you eventually realize that Z just has to be 1. Because Z can't be 2. Because a single digit plus a single digit plus a double digit can't make something over 200. So Z just has to be 1. And then you also realize that Y just has to be 8 or 9, I think. Because if Y was 7, you can't get 2 single-digit numbers to add with 77 to make a 3-digit number. So Y has to be 8 or 9. And then you think, okay, well, how do you get, if there's an 8 here, for instance, how do you get a 1 here? Well, okay, well, maybe you're aiming to get 11 with a 1 carried over, but then you would need 1.5 plus 1.5 plus 8, and that doesn't work. You could try to get to 21, but likewise, 21 take away is 13, and you still can't halve that. So actually, y equals 8 doesn't work. You can't find an x that will work for it. But y equals 9, well, if you did 1 plus 1 plus 9, that gives you 11. Or you could do 6 plus 6 plus 9, which would give you 21. Now, it actually turns out that using x equals 1 doesn't work, because of course 1 plus 1 plus 99 is 102. Sorry, is 101, sorry. And then, of course, this says that doesn't work. But if you use a 6, then it does work. And so the answer will be 6 plus 1, 6 plus 9 plus 1, I guess. And the answer will be 16. So 100 is multiplied by either 2 or 3. So, okay, we're either going to get 200 or 300. Then added 1 or 2. So we're either going to get 201, 202, 301, 302. Finally, we're now divided by 3 or 4. So let's just try all these things. What happens if we divide them by 3? Well, that works. We get 67. So the answer is either 67 or more than one final answer is possible. You can't divide that by 3 because the digits don't add up to make a multiple of 3. Likewise this, likewise that. So, okay, that's all fine. The only answer so far is 67. But now let's just divide them by 4, except none of these divide by 4 because they're all got remainders. 4 just goes to multiples of 100. So none of those work. And so 67 is the only one that actually does work for our answer. Now, to get the biggest difference between QS and PR, we need Q to be as far away from P as possible. Like, I think that's just all we need to think about because those are the 10 digits, those are the most important. Make Q as far away from P as possible. Now, these are all in ascending order. So I think if I make P1, I can't make it 0 because it's a 4-digit number. So let's make P1. And then to make Q as far away from it, I think I can make that a 7 and then just go 8 to 9. Because I can't make Q as a 9 because they're in increasing order. And I think increasing means that they can't be equal. So I can't go 1, 9, 9, 9, I don't think. So I'll just get this and I'll guess that's the answer. Let's just take away QS from PR and we end up at 61. I can't see how you're supposed to make that. So I was just pretty confident that it must have been 61. For this question here, apparently the 3 faces on R make 14. So let's just make up some numbers. Why not? Let's make 5, 5, and 4. As that back face of it there is 4. The vertices the faces at S make 16. So that's got to be 4, 5, make 9 so far. So let's make that a 7. And then the faces at T make 24. I've already got a 7 here. So that leaves behind 17, is that right? So let's just go with an 8 and a 9, maybe. And then the vertices at U add up to 8 plus 9 plus 5, which is 22. That must be the answer. It doesn't matter what I put down here. Otherwise, if there was an answer that said, more than one answer is acceptable, then I couldn't have used this method. But the fact that there were only these answers and I have an answer of 22 means the answer must be 22 without any more effort given. A train has 12 carriages. Each carriage has the same number of compartments. 7th carriage, 50th compartment. So if the carriages had 7 compartments each, which is what part A says, we're just going to try out the numbers here, then the 50th would be the first compartment in the 8th carriage. Because, of course, 7 times 7, if there were 7 compartments in each carriage, makes 49. The 8th carriage would have the 50th compartment, the first one. So it's not A. In B, you'd have, of course, 8 times 7 is, 7 times 8. That's the same thing, isn't it? Okay. 7, is it? Am I even saying the right thing here? The 50th would be the second carriage of the 7th compartment. Because, of course, 8 times 6 is 48. So the first 6 carriages would have the first 48 compartments. So the second compartment on the 7th carriage would be the 50th. And so this is the right answer. You can check that 9 gets you, she'd be in the 6th carriage if there were 9 per thing. And so, so obviously wrong as well. And we have our answer. Now here, there are some smart mathematical ways of figuring out how many ways to put the kangaroos in here, such that none are next to each other. However, when you look at the numbers here and see that the biggest one is 11, I immediately thought that actually I could just count the things. Like, I'm not going to be sitting here making that many pictures because at most it's 11. So I just sat here and I made all the pictures. Obviously, I didn't draw kangaroos because who does that? But I just worked out all the places, starting with a kangaroo in the far left, all the places that the other kangaroos could go. I tried to do it as methodically as I could, spacing them out, going further and further to the right. And then I put a kangaroo in the second carriage, or second place instead. Not doing trains anymore, are we? And it looks like this. And I just figured, again, I'm maximum going to have to do this for 11 of them. And it turns out you only have to do them for 10. There are 10 of them. You can't go any further than this. And you're done. By the way, when you get here, when you're testing this last one, you can't put a K here because that will just make it the same as one that you found before. So there are only 10 of them. 23, I'm not very happy with 23 because I think that the way that I've done this is not really something year 7s and 8s would do. Maybe I'm wrong. But I called the sum of money X. And then I said Joe took £10 plus a quarter of what was left. That algebraically looks like this. She took £10 plus a quarter of the total money, take away the 10 she'd already taken. This is a quarter of the money that's left. The total amount, take away the 10 that she already took. Now, Flo takes 40 plus, and this is where I think year 7s and 8s would struggle to form this algebra, 40 plus a quarter of what's left. Now, what's left is 3/4 of what was there before. So this is a quarter of what was left. So 3/4 of that minus the 40 that she already took, and she takes a quarter of that. So I hope that kind of makes sense. She took 40, and then she takes a quarter of what was left. And what's left is 3/4 of what was originally left, minus the 40 that she took out before we did this calculation. Now, it says that these two people have the same amount of money, so we have to set those equal to each other. I times everything by 4, and then I times everything by 4 again to get this. And then eventually you solve that. It all works out quite well in the end. You get x is 330. And then you can just run through it. So Joe took 10, that leaves behind 320. She then took a quarter of that. A quarter of that is, 80, I think. So take that away, and there's now £240 left. Flo takes 40 of that to take it down to 200, and then a quarter of that, which takes you down to 150. And so Mo therefore has 150. I think there must have been more sensible ways of doing that, but whatever. Now, because these distances are in order, the furthest 2 points away must be 14 away from each other. And now the closest 2 points obviously must be 2. But notice how 2 plus 12 make 14. So I reckon we just must be using those two together to do that. And likewise, 3 plus 11 make 14. So it's tempting to use that. Well, I mean, we are going to use it, I think. But we can't use it, I don't think, from the edge, right? Because if we have a distance of 11 coming out the edge, maybe, we are going to use it from the edge. Sure. Just make 3 plus 4, 11, make 14, and then, sure. We couldn't do it from this one, I don't think, because then if we went 11 away from this one, there'd be a distance of 1 away from here, so we have to go from the edge. And just say that because those make 14 in total, those kind of act as a pair in the same way that 12 and 2 do. But anyway, the remaining distance we haven't got is between this one and this one, which must be 11 away, take away this 2, so that makes 9 away in total. And yeah, sure, drawings always help. So we have a cube that's made up of 64, I guess, smaller cubes, and we're going to paint them red and blue, 3 reds and 3 blue faces. Now, because no cube has 3 red faces, that means that we cannot go red, 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 like all together, because then this cube here would have 3 red faces. So it can't go red, 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 and blue, blue, blue behind. What must be happening is it must be going kind of around, and you've got like red, 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 and then underneath, like in 2 U shapes, if that makes sense. Like red, 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 and then blue, blue, blue going underneath, because that means all the corners have at least both colors, essentially. So I think that was my logic. And then, well, how many cubes have both red and blue faces? We'll just count them up, right? It's basically most of the ones on the edge. For example, all of these edges, all of that edge, and all of that edge, but not these two, because these two just have blue and blue next to each other. Obviously, none of the middles have red and blues, because all the cubes in the middle, and of course all the cubes buried in here that you can't see, those aren't painted at all. But these cubes in the middle here are only painted on one side, blue or red. So none of those count. But these outside edgy ones do count. I've just sort of coloured them in. And you work your way around, being careful not to colour in like these two or these two. You just work your way around. You've got to imagine behind here, underneath, you've got another 3 more along here because of this red and this blue, and then another 3 more going down here. Actually, only 2 more, because then otherwise you'd be counting this corner. Kind of a visualization trick, isn't it, this question? But anyway, when you add those all up, or alternatively, of course, you could just do 64, take away all the ones that only have 1 color or no colors. Eventually you end up with the answer of 24. And that is the entire challenge done. Thanks for watching.